What is the quantity of electricity required to deposit 1 to 8 grams of copper from molten copper to chloride? Hello guys, welcome to Learn Chemistry with Onye, and today we're going to be solving a question on the electrolysis. And like the question said, we're looking for the quantity of electricity required to deposit 128 grams of copper 2 chloride. So what's copper 2 chloride? This is copper 2 chloride. Okay, all right, so this is copper 2 chloride, and what it doesn't mean, what does molten means? We hear about a molten compound is a compound that has been heated from a solid directly to a liquid. What do I mean? Is that this copper 2 chloride was heated till it became a liquid. It wasn't dissolved in water, unlike when you hear an aqueous solution. An aqueous solution is a compound that likely have been dissolved in water. But over here, copper 2 chloride did not dissolve in water. Hence, if a current passes through this, it's going to dissociate. However, it won't have it's not going to have hydrogen or hydroxyl ion. So this is going to have copper ion and chlorine ion. But if this was an aqueous solution, you're going to have both hydrogen and hydroxyl, and this is water. However, because this is molten, this is just what we are going to have. All right. So this is going to be deposited at the cathode, and this will be deposited at the anode. Now, for this question, the question says deposit of copper. So we're going to be talking about copper. What is deposited at the cathode? So if copper is deposited at the cathode, it's going to require 2 Faraday of electricity to become stable. All right. So copper requires 2 Faraday to become stable. So this is the equation we're having here. So come back to the question. We're asked to find the quantity of electricity. Now from here, the 2 Faraday of electricity, we can find quantity of electricity. So from here, 2 Faraday of electricity requires, it's going to deposit 64 grams of copper. So 2 Faraday of electricity is going to deposit 64 grams of copper. What is the quantity of electricity required to deposit 128 grams of copper? So what's the quantity of electricity required to deposit 128 grams of copper? What is F? Come here. F is 96,500. So I'm going to replace F here with 96,500. So I have 2 times 96,500 to give me 64 grams, and X 128 grams. So what's X? So your X is equal to 128 times 2 times 96,500 divided by 64 grams. So let's calculate this. We're going to have 128 times 2 times 96,500 divided by 64. So 386,000. So we have this, it's going to give us 386,000 column. Remember that this is measured in column, and this will cancel this. So gram is going to cancel gram, and this is measured in column. Now we have 386,000. However, what we have here is in standard form. So there's a decimal point here. We go 1, 2, 3, 4, 5. 3.86 times 10 raised to the power of 5 column, which corresponds to B. So B becomes our answer. Hope you understand this.